Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2623 indicates a malfunction in the high-pressure fuel pump spill valve on the 2016 to 2022 Honda Pilot models. This component is critical as it manages the fuel pressure within the fuel system, directly affecting engine performance. Specifically, the high-pressure fuel pump spill valve regulates the amount of fuel returned to the tank when fuel pressure is too high. If this valve malfunctions, it can disrupt the fuel supply and lead to potential engine issues. An effective troubleshooting process is necessary to resolve this code, and it begins with confirming the presence of P2623 alongside any related injector circuit troubles such as P0201 through P0206. This ensures accurate diagnostics and effective repairs in the vehicle's fuel system. DTC P2623 refers specifically to the high-pressure fuel pump spill valve malfunction. This valve is integral to maintaining correct fuel pressure in the system, ensuring the engine operates smoothly without any hiccups. The spill valve is typically located in the fuel pump assembly and connects to the high-pressure fuel lines. Its primary function is to route excess fuel back to the tank whenever fuel pressure exceeds what's necessary for engine operation. A failure in this component can lead to various fuel system malfunctions, causing efficiency issues, or even leading to engine stalling if not addressed promptly. Understanding the role and location of this component is crucial for effective troubleshooting and repair. Several potential causes can lead to the P2623 DTC. Firstly, a faulty spill valve may stop regulating fuel pressure, yielding excess pressure or stalling the engine. Next, wiring issues can arise, leading to disconnections or shorts that impair the spill valve's function. Corroded or damaged wires may create an open circuit, as can loose terminals or poor connections to the engine control module, PCM. Another consideration is the injector relay, which can fail to send power, impacting the operation of the high-pressure fuel pump. Each of these causes must be evaluated to pinpoint the root of the malfunction and apply the correct fix. The symptoms associated with DTC P2623 primarily center around engine performance issues. Drivers may notice that their vehicle reacts sluggishly, indicating that the engine is not receiving optimal fuel pressure. Stalling or difficulty starting the engine may also occur, stemming from fuel saturation or delivery issues caused by the malfunctioning spill valve. Additionally, the check engine light will illuminate, signaling a system fault that requires immediate attention. Observing these symptoms can lead to a timely discovery of the underlying issue, allowing for prompt troubleshooting and repair actions to be taken to restore vehicle health. The first step in troubleshooting DTC P2623 involves problem verification. Ensure the vehicle is turned to the on mode, allowing the onboard diagnostic system to initialize. Then, use the HDS or Honda Diagnostic System to clear the current DTC. After that, turn off the vehicle and restart the engine. This helps to establish if the P2623 is still present or if there are any pending or confirmed DTCs relevant to the same issue. This step establishes a baseline for further diagnostics, as DTCs can sometimes resolve without intervention, indicating temporary faults. In the second step, turn the vehicle off to ensure safety and prevent any electrical mishaps. Next, remove the injector relay. This relay controls the operation of the fuel injectors, and its proper functioning is essential for engine operation. Testing the injector relay is critical. It verifies whether the relay is operational. If the relay tests as bad, it needs immediate replacement. since a faulty relay will prevent the injectors from receiving power, directly impacting fuel delivery and potentially causing DTC P2623 to appear. Ensure that all connections and components are intact before moving to the next troubleshooting stage. Step 3 involves checking for an open circuit in the +B INJ line. Measure the voltage between designated test points while the vehicle is off to avoid any accidental shorts. Ensure the injector relay remains disconnected during this test. This process helps identify if battery voltage is present at the relay socket, which is crucial for injecting correct voltage to the fuel system. If voltage is confirmed, it indicates that the +B INJ wires are intact, allowing further progression to later troubleshooting steps. If voltage is absent, proceed to the 4th step for fuse inspection, as an open circuit issue could very well be the cause of the system fault. In the 4th troubleshooting step, focus on checking the fuse related to the injection system. Specifically, inspect fuse number A12. This fuse plays a pivotal role in supplying power to the injector relay and consequently the fuel system. If the fuse is intact, an open in the +B INJ wire between the fuse and the injector relay should be repaired. If the fuse is blown, it must be replaced as it prevents the system from receiving adequate power, essential for operating the components involved in fuel delivery. Knowing the exact role of this fuse allows for targeted diagnostics and effective repair work. Step 5 is focused on evaluating the voltage condition of the injector relay. With the vehicle turned to the on mode, proceed to measure the voltage between specified test points. This test ensures proper function of the relay and evaluates the integrity of the associated wiring. If battery voltage is present, it suggests that the B INJ wires are functioning correctly, allowing the system to proceed to the completion of troubleshooting steps. However, if no voltage is detected, the next step is an essential follow-up to inspect for any issues within the MRLY line, which could involve more extensive diagnostics or replacements. For Step 6, turn the vehicle off and begin by jumping the SCS line with the HDS to prepare for further testing. After waiting more than 1 minute, disconnect the PCM connector A, which will allow you to focus on the wire integrity in the MRLY line. Measure for continuity between the specified test points at the injector relay socket and the PCM. Confirming continuity indicates that the MRLY wire is intact, which is essential for power distribution throughout the system. The evaluation of the MRLY wire helps identify if it's functioning as designed or if further repairs need to be undertaken. In this 7th step, attention must be directed to the INJ-RLY outline. Begin by ensuring the vehicle remains in off mode while you disconnect the PCM connector A. Following that, connect the designated terminals with a jumper wire to secure the circuit for testing. This will allow you to measure voltage between specified PCM pins and confirm that battery voltage flows correctly through the INJ-RLY out wires. If voltage is present, this indicates that the internal connections are functioning well. If absent, it necessitates a check for any open circuits in the wire connecting these points, which will inhibit proper function of the fuel system. Moving on to Step 8, the focus shifts to checking continuity in the HP plus B1, FP plus B1, and HP minus B1, FP minus B1 lines. After reinstating the injector relay, prepare to measure continuity between specified test points while the vehicle remains off. Establishing continuity will confirm that these critical wires are intact and properly conveying power to the high-pressure fuel pumps. If continuity is confirmed, it signals that these lines are functioning and the issue likely lies elsewhere. Otherwise, if there is no continuity, it prompts further investigation into the open circuits that could be affecting these wiring lines. In the 9th troubleshooting step, disconnect the high-pressure fuel pump's 2P connector to assess wiring issues. Measuring continuity between defined test points at the pump and PCM will help identify if the HP plus B1, FP plus B1 wire is open. This step is significant as an open wire would prevent the high-pressure fuel pump from receiving the power it needs to operate effectively. Confirming continuity indicates that the wiring is intact, and it allows you to move forward. If continuity fails the test, that could indicate a need for repairs in the wiring between the PCM and the fuel pump. Step 10 requires attention to the HP-B1, FP-B1 wiring. As with previous checks, ensure that the high-pressure fuel pump's connector is disconnected while measuring continuity. This check helps pinpoint any faults along the HP-B1 line, directly affecting the fuel pump's performance. If continuity exists, it indicates that this wire line is functioning properly. If a break is found in the wire, it will necessitate repairs to restore function and prevent ongoing DTCs. Establishing a solid connection is crucial to ensuring that the pump receives the necessary support from the PCM. Step 11 involves checking for any short circuits within the HP plus B1/FP plus B1 line. With the vehicle turned on, measure the voltage from specified test points with the high-pressure fuel pump connector still disconnected. Confirmation of voltage indicates that there's a short to power present somewhere along the wire between the fuel pump and the PCM. Correcting this issue is vital, as the presence of a short can lead to failure or malfunction of the entire fuel delivery system. Addressing any found shorts ensures that the integrity of the entire system is restored, achieving consistent engine performance. In Step 12, focus shifts to the HP-B1, FP-B1 line, assessing for potential shorts to power. While measuring voltage between the designated test points, it's critical to ensure the high-pressure fuel pump connector remains disconnected. If voltage is detected, it confirms the presence of a short that must be rectified. Following through with repairs in the affected wire ensures that the circuit functions correctly and minimizes the risk of future DTCs. Being meticulous during this step safeguards the reliability of the vehicle's fuel delivery system, which is essential for maintaining engine health. Step 13 involves assessing the HP plus B1, FP plus B1 line for shorts to ground. In this instance, you'll conduct a continuity check while ensuring that the high-pressure fuel pump wiring and PCM connectors are disconnected. Confirming continuity implies that the HP plus B1, FP plus B1 wire is in good condition. If continuity fails, it means that there's a short to ground somewhere on the wire, which can disrupt the functioning of the fuel pump. Identifying and repairing this condition is vital to restoring fuel system integrity. It's an essential step in ensuring that the components downstream of this wire operate without failures. Upon completing the troubleshooting and repair steps for DTC P2623, a final verification process is essential. Initially, confirm that there are no remaining diagnostic trouble codes, DTCs, present in the vehicle system. This is done through a diagnostic scan using the HDS system. Following this, perform a test drive to evaluate the vehicle's overall performance, ensuring that the engine runs smoothly without hesitation or stalling. It's also important to monitor for any additional symptoms that might suggest unresolved issues. Completing this process confirms that the repairs address the problem associated with the high-pressure fuel pump spill valve, thus restoring the vehicle's full power and efficiency. To prevent issues like DTC P2623 from arising in the future, regular preventive maintenance is key. schedule periodic inspections of the fuel system to ensure all components, including the high-pressure fuel pump and spill valve, are functioning correctly. Check the condition of wiring and connectors to prevent corrosion or disconnections that can lead to faults. Monitoring engine performance regularly can also catch potential problems before they escalate into serious issues. Keeping a close eye on these components through a preventive maintenance schedule can save time and money while ensuring the reliability and longevity of the vehicle. In conclusion, understanding Diagnostic Trouble Code P2623 is pivotal for maintaining the 2016 to 2022 Honda Pilot's performance. This code suggests a malfunction in the high-pressure fuel pump spill valve, which necessitates a systematic troubleshooting approach to identify and resolve the underlying issue. The troubleshooting steps guide technicians through careful inspections and tests to ensure that all components are functioning correctly. Additionally, regularly scheduled maintenance is crucial in preventing future occurrences of similar DTCs, helping to preserve the longevity of the vehicle and enhance driving experience. By following the outlined steps, technicians can effectively address issues related to the fuel system, ensuring optimal performance. Please like and subscribe to the channel. See you next time.